Welcome to our lesson on the ideal gas law. Today, we'll solve a practice problem step by step using PV equals nRT. Here's our problem. A container holds 2.5 moles of an ideal gas at 27 degrees Celsius and 2 atmospheres of pressure. If the temperature is increased to 127 degrees Celsius while keeping the number of moles constant, what will be the new pressure if the volume remains unchanged? Let's solve this step by step. First, since volume and number of moles remain constant, we can use a simplified version of the ideal gas law that relates pressure and temperature. We can write P1 over T1 equals P2 over T2. Before we can use this equation, we need to convert our temperatures to Kelvin by adding 273. 27 degrees Celsius plus 273 equals 300 Kelvin, and 127 degrees Celsius plus 273 equals 400 Kelvin. Now we can plug our values into our equation. We have 2 atmospheres over 300 Kelvin equals P2 over 400 Kelvin. Solving for P2, we multiply both sides by 400 Kelvin. This gives us P2 equals 2 atmospheres times 400 divided by 300, which equals 2.67 atmospheres. Let's visualize what this means. As we increase the temperature, the gas molecules move faster and collide more frequently with the container walls, resulting in higher pressure. Let's summarize what we learned. When we keep volume and number of moles constant, pressure and temperature have a direct relationship. As temperature increases, pressure increases proportionally. In this case, increasing the temperature by 100 degrees Celsius caused the pressure to increase by 0.67 atmospheres.